Hello everyone. This is how to build a Tetris game using Python and the Pygame library. So this is going to be video 3 in the series of videos that I'm making. So in last video we saw how to make the Tetris class and the figure class. So in this video we're gonna put we're gonna build the main function, the main method, and we're gonna add the attributes and the methods and the game loops that are required for the main method. So let's get started. So for now, I have an empty main method and we're gonna code along and I'll explain as I go. So let's start. So we're gonna start with accessing the global variables. So we're gonna say lines to clear and level global variables will be accessed through in the main method. And to do that, we need the global keyword. So that's why we have global there. Next, we're going to instantiate the screen height and width. So this is going to be the width and height of the game screen. Game height and then game width. So this is going to be the height and width of the game. So it's going to be 20 tiles high and 10 tiles wide. So it's going to be 200 tiles in total. Next, we're going to instantiate the pressing down Boolean value. This pressing down Boolean value indicates the game if you're pressing down the down arrow key. If you're holding it down, this will stay true. And if you let it go, then it becomes false. It lets the game know when you're holding the down key. So it can fast drop the figure objects based on your keyboard input. This game over variable is to indicate when the game is over. Counter variable is going to be useful in tracking the time of the game. And FPS is also going to be a clock variable used to track the time of the game. Next, we're going to instantiate Pygame by saying Pygame init. Next, we're going to make the game window by saying Pygame display set mode screen height screen width. So this will create the game window. This will create the main window that'll hold the game and the grid. Next, we're going to create the clock Pygame time clock. This will keep track of the time in the game. So that's going to be useful. Next, this is important, we're going to instantiate the Tetris class and save it to the game variable. So I'll say game height and game width. So we're passing in the size, the height of the game, and the width of the game into this game variable. Next, we're going to build the while loop. So while not game over. So as you see, game over is false. So while not game over, so this will automatically run. If game figure is none. If there's no game figure, we want to create a new figure. So that's why you call game.create figure. So in the Tetris class, we can see over here, we have the create figure method, which we'll call to instantiate a figure instance. Okay. So now that a figure instance is created, we're going to increment counter by 1 to keep track of the time. If counter is greater than 100,000, then we reset the counter. We do this to make sure that each block falls at a specific speed. If we didn't do this, the blocks would fall very fast because the while loop goes iterates through this lines of code very quickly. So this is why we need the counter variable to reset after 100,000 to make it slow down. Although this is not the full implementation, so it's coming up right here. So we're going to say counter modulus FPS divide by level divide by 2 equal to 0 or pressing down if game state is start, game dot go down. So this is the function this is the method that calls the figure object to fall down at a specific speed. If we didn't have this, it would instantly fall down at a very fast speed. So we need to control that speed using this logic you see right here. And we need to check that the state of the game is start and not game over, because if it's game over, we don't want figures to fall down. Then we'll say now we're going to build the event loop to get the keyboard inputs for the game that the user will enter while playing the game. So we'll say event type Pygame quit. So this is the quitting loop. If the user suddenly decides to press the X icon at the top of the game window, it'll go through here. Or if he or she decides to press the escape key, sorry, not for the escape key, that one's coming up. So if event type Pygame key down, if event dot key is equal to the right arrow, then we say game go sideways. So this is saying if you press the right arrow, go sideways by 1, which indicates the game to go right. Next, we're going to put the opposite of that. So if Pygame key left, game go sideways, and here we're going to say -1. So this makes sure that the sideways method knows to go left. Left for -1, right for +1. Okay. Then we'll say for the up arrow, Pygame up. For key up, we will say game rotate. So if you press the up arrow, this is going to rotate the figure to the next rotation. And if it's at the end of the rotation array, it's going to loop back to the beginning, as you saw in the previous video. Now we come to key down. Key down is what makes the figures fall at a much faster speed, so fast dropping. In this case, we say that pressing down is true to indicate to the main method that the figure needs to fall at a much faster speed. And then we create an exit condition by saying escape. If you press the escape key, then we're going to say Pygame quit and then sysexit 0. So if you press the escape key, it immediately closes the window, the main window. So that would be useful if the user wants to suddenly quit. Now coming out of the for loop, we're going to say event type Pygame key up to know when the user has released the down key. This will be used. Pygame key down, key down, and then we'll say pressing down false. So what this is saying, if you hold the key, if you hold the down key, it goes through here, and pressing down is true. If you release the down arrow, it suddenly goes through here, and pressing down is false. Okay, that's how we check whether it's if the down arrow is being held down. Now we're going to fill the screen, the whole window, with the white background color. So the game's going to have a white background. Then we'll make double for loops to draw the game grid for j in range game width. And we're going to say Pygame draw rect window. This is where we draw. This is the location to draw, and it's going to be a gray color. And now we're going to use a bit of a complex formula to make the grid. So bear with me here. So game zoom times j, game start y, game zoom times I, game dot zoom, and then game zoom -1. So what this is doing is it's creating the great game grid using the game.zoom variable to space out the grid evenly. So there's going to be a line next to a big space, next to a line, next to a big space, next to a line, and that's what creates this game grid. And at the end we say 1. Okay. Now we draw, we say if field, if game field ij is greater than 0, so if that particular tile is occupied by a fixed figure, then we draw that color onto the game. Game field ij and then game start x plus game. So here you see the same formula. It's a reoccurring formula that you'll see. It just helps us draw the game grid. So game dot zoom times I times I game dot zoom -2 game dot zoom -1, and that's it for the double for loop logic that will draw the game grid. So I'll just make a comment here. Draws game grid Okay, so now we'll draw the figure on the main game grid, and we do that by saying if figure is not none. So if the figure exists, then for I in range 4, because remember this is the figures are drawn in a 4x4 matrix, so we always have to say for range in 4, and then we use this formula p I times 4 plus j if p in game figure dot get image, and now comes pretty much Pygame draw rect, so this might be a bit complex, but bear with me. So figure color, we're getting the specific color assigned to that figure, and we're drawing it on the screen. And then we'll say start x plus game.zoom times j plus game figure x plus 1 game dot start y game dot zoom I plus game figure y plus 1 game dot zoom minus 2 game dot zoom minus 2 again. So this is basically drawing the figure based on a 4x4 matrix onto the main game grid. Okay, I'll make a comment of that over here. Draws figure instance to game grid. Okay, I know it looks complicated, but that's all it does. Next, we're going to instantiate the font that will be used in the game. So for this game, I'm using this font. So let me get there first. Consolas. So I'm using Consolas size 11, bold, true. And then for font 2, we're going to use Pygame font Comic Sans MS. Again, size 11 and bold, true. Next, we're going to instantiate the score text message that will be rendered onto the screen using font 1. So we'll say score game.score. So we convert game.score to a string in order to put it to the game grid, the game window. Then we say black. So it's gonna be score, and whatever the score is, it's gonna be bold, and it's gonna be black. So that's all this does. Next, we're gonna go text lines to clear, draw the lines to clear variable onto the screen, so the user knows how many lines he or she has to clear in order to get to the next level. Lines to clear, true for bold, and black. So it's basically the same thing as up here, except it's going to be lines to clear, convert lines to clear to a string, and then draw it to the game screen. Next, we're going to draw the game over message. Game over 1. So font1.render game over. It's going to be in bold, and it's going to be color black. Next, we're going to draw the second game over message, which tells the user to press escape to exit the game. So we'll say press escape, true, black. Okay, so now we're done drawing the game text. And now we just have to position these variables onto the screen. So by doing window.blitz, it tells Pygame where to position the text core variable on the screen. So it's going to be 100 from the left and 20 down. So it's going to be left and top. So kind of like a XY coordinate used to position these variables. Next, we're going to go lines to clear. Same thing here. And we give it 250 to 20. Then we say window blit text level to show the level of the current game onto the screen. 255 for this one. If game check level up. So check if the game can level up. And if it does, we're going to run the main again. So this is basically restarting the main method if the game is eligible to level up. So let's say you're in level 2 and you clear 2 lines. Now you can move on to level 3. And in order to do that, we recall the main method. By recalling the main method, it's going to get rid of all the fixed figures on the screen and basically restart the game grid, but not the game variables, right? Like the score is going to remain the same. The lines to clear will change to 0, but the level will be incremented by 1. So that's what we're doing here. We're basically going to the next level. Next, we check if the game is over. So if game state, game over, window blit, and now we show the game over text at these specific coordinates. Now we add the second message, game over 275. Okay, so basically if the game is over, show the game text variables onto the screen at these specific coordinates. Okay, then we say Pygame display.flip. What this does is it refreshes the screen whenever the frames go by. So as the time goes on, we continually have to update the Pygame screen in order to reflect the changes that are made by the moving block, the rotations, the sideways movements, if you cleared a line, if the text, if the score gets incremented, if the levels get incremented. So this is what makes the Pygame window update itself continually. And lastly, we say clock tick FPS. So this is not vital, but it helps us keep track of the game. Clock tick FPS. So FPS has a value of 30. So we're going at 30 frames per second. Okay. Just delete some empty lines here. Okay, so we should have a working game. Also, there are some errors that I made in video 2 that I want to address in this video. So in the figure classes self.color in the constructor, previously we said self.colors, but that variable doesn't exist. So now we change it to colors to refer to the global colors list right over here. So we're getting it from here. We're getting colors from this array of tuples. Okay, and there's another error that I want to bring up. So in Go Sideways of the Tetris class, there was the line 125 where it says if self intersects. Previously it was intersect, just add an S because that's the name of the intersects method and it has to match the name for Python to be able to call it. So now we're going to run this, and if any issues come up, we'll debug them. Issues should come up as it's part of programming. It's rare that you get to run a program first time with no issues, so I'll address any that come up. Okay, so Pygame main.py, and it's loading. Okay, so in line 245, there's an error. Has no Pygame font attribute, has no attribute sys font. Okay, so this is the error. So the F should be capitalized. So sys font. Okay, let's run it again. Give it a little while. Okay, so text level is not defined. Text level. Oh, sorry, I missed something. Sorry about that. So over here we say render level, right? To show the level of the game to the user that's playing it. And we'll call the global variable level. As you remember, at the beginning of the video, I made global level and global lines to clear so that we can access it further down in the main method without having to call global again. So that keeps our code dry, which stands for do not repeat yourself. Okay. Okay, so let's see again. Give it a little time. Okay, so, okay, as you see, we have, okay, now this is the test. We will make sure that the score gets incremented, and as you see, the score moves to 1, and the level moves to level 2, lines to clear is 2. So that works. Okay, so here comes the second line. Okay, lines to clear 1. Okay, so now we know that works. So now it's in level 2. Okay, let's keep going. Let's try to clear one more line if we can, just to make sure that everything works as we intended to. Okay, let's try to clear this line. Okay. Boom, there we go. Now we're at level 3 with 3 lines to clear. And as you see, the game speed is starting to increase, if you guys noticed that. So now, as you go up the levels, the harder it gets. I personally have not been able to get past level 3. But yeah, so now it hits the top of the screen and the game is over. So now if we press escape, it exits. So there we go. A fully functioning Tetris game built using Python and Pygame. So I will post the source code for this in a GitHub gist repository. I'll include the link in the description, so make sure to look out for that. I will also include the links for some blog posts I made. I made 2 blog posts specifically for this Tetris game application that goes into detail of what the various function methods are, what the attributes does, what the game loops do. Basically, this video in text form. So you can check that out. I'll link that in the description. And this should be it for this video and this video series. If you found this video helpful and this video series helpful, please like and subscribe. It helps me out a lot. And thank you all for watching. And thank you.